I think I can now just say, now is the start of the stream. All right, well, I hope you're all having a great Thursday so far. Mine seems to be going swimmingly, but hopefully we'll get better. I don't have very many meetings at work, which is always a good day to look forward to. But okay, let's take a look. So last time in our flocking rust, what we attempted to do was insert a velocity into our world. And this ended up causing a problem because we can't actually we can't actually put in like a location and a velocity together at the same time. I think we got this to work, but what we had initially wanted to do was do something like take the velocity here and put it up here, so they're associated. So at least it feels like they're associated together, like that. The problem is, if I do that, we get an error saying, hey, we can't have like two different types that are coming together into the same vector. That's not a cool thing to do. So we have to fix that. All right, the way we're gonna fix that, let me just undo that for a second. We're gonna come back up into BB ECS or mod for the world. I'm thinking instead of insert entity, I want to get rid of that and replace this with like a spawn, and use sort of like kind of a builder pattern. It's gonna be a like we spawn entity and then like with type methods. So it's gonna be two methods that we're gonna add in here. So here's what I mean. I'm gonna switch to spawn entity. We're gonna create a new world. We're gonna create a test location, and then I want like a separate type in here. So it doesn't really matter what this is. This could just be like, we could just say, okay, like our velocity is equal to like some tuple, 32, 34, so something like that. It doesn't really matter what this is, as long as it's a separate type than what we have up here. So I'm gonna say, we're gonna spawn entity. I'm not gonna pass anything in, but from this, I'm gonna then just do with component, and then we're gonna pass in. So I'm curious, like, can I pass in like location here? With component velocity. And I want them to, like, as I'm doing them, they can insert into data. So it'll be sort of like calling insert on each individual one. We won't have a vector that we loop through now. Now it'll just be sort of like a one-to-one. Hey, we called with component, and it throws it into the data. Then, if we want to get this data out, so we're going to get you out. We're going to get location type, and we can see that our data is the same as location. That's fine. We should also be able to do the exact same thing to get out everything else. So let's do that. So these should be location data. And I want this to be velocity data equals world.data data get, give it a reference to the velocity type ID. We unwrap that, so that gives us our vector. We want to choose the first thing that goes in there. Then we need to clone this to take ownership. Once we clone, we can downcast And we have to tell the downcast that you're going to be of type tuple of, what is it? I32 dot unwrap. That gives us this. Okay, perfect. And then I can assert equal dereference velocity data, and you should be equal to velocity. Okay, so now the only thing yelling at us is the fact that we haven't implemented spawn entities. That doesn't exist yet, but our tests are sitting here. So once we have this running, everything should work just fine. So let's go ahead and make these changes. So instead of insert entity, this can be spawn entity. We're not going to take anything in whatsoever. It's just going to be it's just going to be this. And I think what we want to do is we want to turn a reference to mutable self. So at the end here, we'll return self like that. I don't need any of you. So that should make you fine. But then we have this with component that's going to take in one of these. Okay. So, okay, with component, I'm thinking that this is going to take in. Well, okay, so we have a couple choices here. I can take in and use impl any, or I can use generics with this. If I use generics with this, let's try that. So if I use a generic, so like if I do something like, okay, this is going to be a component. See, that it makes it look like it's a struct. If I do that, I don't want to do that. Okay, so we're gonna have like component C. Then we're gonna take in a mutable self, which is coming in from this. We're also gonna take in the component, which is type C, and we're gonna return a mutable reference to self. So if I just do that, okay, you're happy here. You're happy down here. If I try to run this test, we should get a failure. Because we couldn't unwrap from the data because nothing actually made its way inside of it. So perfect. Let us fix that. So in spawn with the component here, we have this component C. I think what I can do is do a self.data.insert component. And then we return self. All right, so C may not live long enough. So you're coming in as component right here. We're passing you into insert, and you're saying you're gonna die before you get to insert? Oh, you know what? We have to say that the C, at the very least, it implements static. If it's literally any type that's possible, there's probably a type in Rust that won't really work out very well for this. But okay, so we have something, anything that implements static. Hello, Flint, Rusty, good morning. Well, at least for my side. Hello, what am I building? So I am trying to make an ECS library for any simulations or games that I'm gonna make. I haven't really looked up how to make an ECS library. I've done a little bit of code spelunking into like libraries like Hex and Specs, just to sort of like see how they're working. But only from like a very, very basic one. I want to try to do this on my own before I go and look up how, like, the official way to do it. I feel like that will help me learn a lot more about how to do an ECS library. And then I'm also building a flocking simulator that's going to use this library right away. Okay, so I have this. If we then run this test, everything passes. Does it relate to my day-to-day work? Absolutely not. Nope. I'm a technical team lead at a health training creation simulation company. So I don't make games or game type things. Other teams do. I'm on the web dev teams. So I do a lot of web dev at work. And management and leadership, that kind of stuff. All right, so we have this spawn entity. What we can do here is maybe just a little bit of documentation to sort of like, hey, what is this and how does it work? So for spawn entity, we want to so begin to begin spawning an entity with all of its components into the system, into the ECS data. Can't do that all in one go, fortunately. So we are using a builder style pattern. So you said that if you ever passed an interview and got a job, you can come back here and let you know. When was that? That was last year. Was that like in November? I don't remember, but so you're back here, so that means you have a job, right? It's good news, right? Yeah, November. Okay. I remembered it was like sometime late last year, but I don't remember I couldn't remember exactly when. So tell us about it. What's your how did it go? What job did you get? What position is it? You applied for a front-end dev, but they put you in consultant position. Oh, interesting. Well, companies are funny like that. They can have titles that, they just sort of make up titles for the HR departments. But like, do you still do front-end dev type of stuff, or like what do they have you do? Yeah, they have you at a front end project. They'll put you in. Okay, that works fine. I assume that as a consultant, you're working for other companies. So is it like an agency? No, you still work at the company that you applied into. Okay, that's nice. I know some people, if they're like getting the position of consultant, that means that they're they're being like, they're being sent out to other companies or sent. It could just be they work in-house, but they work on other people's code. Yeah, I don't know. Like the title sounds a little bit confusing. It sounds interesting. Consultants have to do everything right. Yeah, consultant's a very generic title. It's usually reserved for when you like bringing in someone from the outside. So for example, I might have my company hire a consultant to come in to like help teach us about machine learning because we don't have those skills. Or they can implement something that we don't have the ability or want to. That's how we would use a consultant. I would never hire somebody and give them a consultant for my internal like projects. But that's just me. So like people are weird, right? Like, so HR / the board / the company, the CEOs can like, they probably made a decision to call something consultants at one point in time because they thought it sounded cool. So that's just what they got with now. Yeah, like a healthy amount of fear with that is probably okay, but like don't let it bog you down. Like learning and improving is probably like the next, like that's the next step, right? Is getting yourself leveled up so you can be like a mid-level. But congratulations, this is a great next step. Like that first job is super hard, and then after you have that, it's not that it gets easier, it just gets a little bit different and a little bit more like flowy. And it's always easier to find a job when you have a job. Okay, to use this, call spawn entity first, then and chain many to with components as you want. Yeah, absolutely. I'm happy that it worked out and you were able to get a job. That's super great. All right, now let's add in a doc test here. So if you're new to Rust, doc tests are a really cool thing. You basically can run code inside of this this documentation here, and when the like official documentation is created, it'll run this code as well to ensure that it works. That way, if you look at any Rust project, if it has documentation, then that code works. It has to work. It's really cool. So the way we do this is and do let actually we don't have like the ability to keep that. Crybo99, how am I was watching your Docker videos on INE the other day. Oh, you know, I don't know how many people found me from INE. Like I think one other person reached out on LinkedIn to say that they had seen those, but yeah, I get royalty payments every once in a while from those still, and I have no idea like what the reach on that was. I'm glad you're able to see that and find it. So that's awesome and welcome. I'm glad to have you here in like in the live area. And Quittabot, what plugins do I have on VS Code for Rust? So I have Better Toml, just for the highlighting on Toml stuff. Bracket pair colorizer isn't like Rust specific, but it does work with Rust. I've not used it yet, but I've been told that code LLDB is actually really good for debugging Rust. I haven't tried it yet though. Crates is really nice. The crates. No, wrong cargo to Toml. Let's do this one. this crates will actually give me a like checkbox next to these dependencies to let me know if they're up to date or not. And then I can easily come through and like change which dependency that I want. So that's really nice. Rust analyzer, of course. And that's it. WebAssembly, I was using WebAssembly for like debugging WebAssembly when I do Rust WebAssembly code, which isn't too often, but I have checked it out a little bit before. So I hope that helps. Okay, so how do we want to do this? So we have to create a world first. So let new world equals world new. So we create the new world and then Dota 2 attitude. Hello. How are you doing today? And then we could just spawn the entity. So if we need to like create something. So let's do like let's see. I think what I can just do is world.spawn entity dot with component. Do I have any hobbies besides coding? I'm trying to get into like a physical build type hobby. So like not fully woodworking, but maybe like making little IoT projects. I recently took an engineering course. That's why I took let's see. I took January off from streaming, and I took this engineering course with Mark Rober. And so now I want to build a workbench, put it into the garage. Unfortunately, Zilby, he's not here anymore. I might as well turn that off. Zilby is loves to chew on like the tiny wires. He does. I'm so happy. He doesn't care about the bigger wires that like plug directly into the wall. That would kill him. So I'm super happy that he doesn't want to do that. But he loves like the tiny little wires that you plug into breadboards. He just can't get enough of those, to the point where I have to lock him out of the room, and then he just meows at me, begging to come in to steal all my stuff. So I want to create a workbench, put it into the garage, and then I can build all the stuff in there. And then like maybe once it's finished and like Zilby's safe, I can bring it out here. Maybe we can even do some streams once I get all that set up for that. Yeah, so I did the creative engineering course for monthly with him. I signed up super early, so it was a lot like cheaper than what like he eventually is going to be running the price at. Also, I want to do IoT stuff and figure out Rust on IoT, because that would be a lot of fun too. And I think Rust is was like one of several languages that would be really good for it. And I don't necessarily want to also learn C++ just for like little Arduino or other stuff. Wolf, hello. Yeah, I have to call you Wolf. All right. Let's see. So with component, then we give it like this interesting thing. So if I say something like 32 F32, that won't be fine. We'll do that. Something like that. And we could do another one with component. Then I can do like 16 I32. This works. But I should probably mention each component needs to be a completely a unique type. Otherwise, they will be stored together in the data component. I know that you can now do linking in here. I don't know how that works. Let's try this. If I just do data and I send us to data, because if we take a look, I do have in here like this data, like data.rs. Not sure. All right. So this is like nice documentation that we've got now here with this. If we head back to our flocking, now we can do this the way we want it to. So we can say world.spawn entity dot with component you know, I could even do like a component with a name in it, like that's just the stir for like what this is. I mean, that could be interesting. That could be interesting, but I don't think we need to. So like these are all going to be birds. Like the only things we have in a flocking simulator are birds. So that's another reason why I'm using this as an example before I go into like a game, because everything's going to be the same. We'll probably have to update the ECS as we get more complex. Okay, so the location and the velocity is what we're really, what we really care about here. So we're gonna say location new, and let's just do like 50.0, 50.0. Then with component velocity new, and I'm gonna do 0.5, 0.5. Then I want to do another one. So world.spawn entity for a second component. So with component location new, let's do like 150, 150.0. So it'll be like a little bit farther down and to the right. With component velocity new, and I'll just do another 0.5, 0.5. So they'll stay the same distance away from each other. All right, so what are you? You need to be capital L. Okay, so now I have these components all over in here. So it's just structs that I've created. Even though they look exactly the same here, they have to be separate. So they're completely separate types because I'm doing a, basically the type is like how it gets stored in the data behind the scenes. How do you get to play this game I'm building? So it's gonna be a simulator, so it's not really play. Right now you'd have to go to the GitHub and download it and run it yourself. I haven't like deployed it anywhere. Also, it's gonna be just a rest, so it's gonna be like a local, like just basically local running. Like it's not gonna run in a browser. Although it'd be interesting if this BB ECS that I'm creating would work. Is the ECS going to be open source? Yes, absolutely. In fact, I can go show you where it is right now. Okay, so I guess I have to refresh to see all the new stuff. Here it is, BB ECS. So here is the ECS, and if we go and check out the flocking, here is flocking. Okay, so given that, if I run this, let's see, we have this systems here, And the system is, so we have a draw system. It's basically looping through all the locations. So we're querying for just the locations and then just drawing based upon that. Now, if I want to update, yeah, here is going to be update locations. So this needs to be run still. But if I run this code, well, okay, so here we have the two birds. They're the locations that we've added in, but we're not doing anything with those velocities yet. So that's the next thing, is to come here, create a system. We need to mutably query for the locations and then query separately for the velocities. So we could do the query for the velocities right now because I don't need that to be mutable. So that velocities equals world.query. Now notice I have to create a new query. So query new with type, and I care about velocity. Okay, so we get this. This gives us a vector here. A vector of the vector. How does that work? Right, because I can query for multiple things. That's what it was. I can query for multiple things. So velocities is always going to be the first one. So in this case, I'm only querying for one thing, so I can just do that. Then we have a vector of all the velocities. Okay, that's fine. Then, how do I want to do this? I need a query to get the locations, but I need to get them mutably. So, okay, back to BB ECS. For the data, we need some kind of mutable query here. So new test time. So function mutably query for data. So how would this work? So we're going to let data, we need to speed mutable. Okay, so let data equals data new. We're going to enter in some kind of entity. It doesn't really matter what it is. So entity equals, we could just do this as like 25. It's this I32. We're going to insert that in. Okay. Then we're going to create our query for this. So that query equals query new with type. You are an I32. So the way I'm doing this is I'm saying, hey, I want to get out of the data all of the vectors that have that specific type. So I can get multiple of these vectors of data. So all my data is really being stored in like a hash map or a dictionary or an object, depending upon what language you're familiar with, of like, okay, all of like the I32s are stored together. All of like the locations are stored together. It's like one of the core components of like ECS systems is like spreading the data out to be in their disparate raw parts. Okay, so I have our query. Now I want to get that query from the data. Okay, so we're going to say let results equals data dot, we're gonna do query mute and then pass it in the query. And we should get a vector. So I'm guessing we're gonna get like a vector out. It's gonna be very similar to this, except it's gonna be a mutable reference. That's what we care about. So we don't have this yet, so let's go start creating it. All right, so we're gonna take in a vec, or we're gonna return a vec with a mutable reference to a vec that has an RC dyn any. So I could just right now, to make this happy, return an empty vector. Okay, so now we have our results back. It's of course an empty vector. Now let's say I want to update that. So like I want to first verify that the data that I got out is exactly what I think that it is. So that should be fine. We have to do this entire fun thing again to get that out. There might be something I can do to like throw that into a helper method inside of ECS that I can call in to like extract. That might actually be really nice. Let's do let so let like queried data is equal to, okay, so results. I know it's the first thing, so I can just go with 0. That gives me this, okay, the vector of the actual data. So I also know that it's going to be that. That gives me the RC. Then I want, so I need to clone this. That gives, so it's a clone of RC. RC stands for reference counting, so I can clone it as often as I want. It's still the same data behind the scenes. And cloning is pretty cheap too. Then I can downcast this. Downcast is taking it from the any and saying like, hey, I want you to be like, attempt to convert this into the type I32. Unwrap it so we don't have the results. We have the actual data. And that's it. So now I have the actual thing in here. Okay, so we have the query data. I want to assert that that's equal right now. So that a destructured query data is equal to entity. If I run this test, we should get a left doesn't equal right. Oh, panicked index out of bounds, which is fine. That's understandable because I didn't actually return with any data in it. So I'm assuming, hey, there's something in that vector, right? No, there's nothing. It's empty. So we need to actually do this query here. So we're gonna say, we can get all the data keys out and then iterate over. And then we do this filter math and we collect. Okay, so it's gonna be very similar to this. So query data keys, that gives me a vector of all of the keys in our hash map. Turn that into an iterator. This doesn't need to be iterator mute at this time. Then I don't see reason not to filter map. Give it a closure. This is going to be a data key. And then I want to do a self.data.get mute. And we hand it a reference to the key, which is this data key. it returns this option, but this filter map is actually really nice. It works really well with this option here. And then we need to collect it together again. And okay, what are you upset about? Cannot infer an appropriate lifetime for auto reference due to conflicting requirements. Expected standard vec mu, okay, RC. Okay, that's too small. It's hard to like read. Let's do the real one. If I run the test, we should get the error. Okay, so here we have on line 40. So right here, we do the self-data.getMute. The lifetime cannot outlive the lifetime. Well, this is like an anonymous lifetime, as defined on the body at 40s. But the lifetime must be valid for the anonymous lifetime number 1 defined on the method body at 36.5. 36. 1, 2, 3, 4, essentially 5 right here. So we have this. So that the expression is assignable with this collect. Oh, okay. So it's saying that, hey, this mute is not going to work for us. You know what I could possibly do is instead say, you know what? I'm just going to return nothing. Absolutely nothing. Now it's going to yell at me and tell me, hey, you didn't reserve nothing. You're returning this. So I can look at what it's actually going to try to return. Okay, so cannot be built from iterator Dyn standard any plus static. I don't think I can do like the plus static in here. So we know it's going to be a vector. Here. Let me try this. If I stay with you with that and I assign this to a variable, temp equals. Now the really nice thing is, I'll just return that right now to make you happy. I can do some, I can basically test things out by like setting types here to sort of see how it ends up working. Maybe what I want to do is do temp here. Then I'm going to see the type show up here. So I want a vec. A vector of, if we look at this, yeah, let's say I just do this to begin with. Okay, so cannot be built of an iterator over elements of type mute standard vec. Okay, so is the mute here or is the mute here? I want to say maybe the mute is here. No, it's not there. It would be here, right? But okay, it's lifetime problems, so where do I put? Okay, do I have to do lifetimes with this? I usually try to avoid having to do lifetimes when writing this code. But that's mostly because like some like both mentors and like other smart people that do Rust programming, like for example Icefoxen, who wrote GGEZ, they've said things like, oh man, if you find yourself manually dealing with lifetimes, you might want to like rethink how you're doing something. That being said, I don't know, like I've also been told that sometimes you run into a situation where you have no choice. Now, when Lifetime Elysian came out, I'd say like that's a lot more true. Rust can handle like figuring out what the lifetimes are very easily. That being said, where do I need to give the lifetime here? Is it possible that my filter map is a problem and I need to figure out something new for this? Let me try. Okay, so we do it. Data keys, we iterate over this. What if I did something like a for each? We have a data key. Then let's say I multi-line this. And I do an if let sum. And this is going to be like the actual data coming from this. So this will be like the raw. This will be like the component. Is equal to self.data.get mute data key. So then it gives me this component here. So we see that there's this mute here. Let's say up here I do a let results equals a new vector. You need to be mutable. And then, so if we have this component, I push you in there. Results.push component. And I return results. I don't need this then. But I still run into the same problem here, it looks like. Okay, so it's not just doing like a filter map. When the self-to-data get mute, hand it the key. It's a okay, do I need to clone this? That's what it is. Okay, so I needed to clone the vec of RCs. Now, if I clone the vector, then it clones the RCs, but then the data should be the same. So, like, it should still be the exact same data. So if I, oh wait, what are you upset about? Mismatch types, expected struct, a vector of mutable reference to a vector found. Okay, so it's still this. It's fully owned now. So let's try this again, but like all together. So I'm just gonna do query dot data keys. We get those. Oh wait, it's just data keys. Turn to an iterator. Then we're gonna do a filter map. Data key. Then I call in self.data.get mute. Handed in the data key. That gives me this option. So, okay, so I have this filter map. It'll strip out all the nones and give me all the sums inside of it. So then I want to map this. And then this is gonna be all like the raw data. So we're just gonna have like the component, the components in here. And then I want to return the components.clone. And then I want to collect them. Capture variable cannot escape fn mute closure. Wait, I don't want to. What did I do wrong? Self.data.get mute data key. Data key is right here. And I want to return you into the filter map. Parentheses look right. What are you upset about? Wait, what's the variable that escaped? Returns a reference to a captured variable which escapes the closure body. Okay. Oh, okay. Can options be cloned? I don't think I can clone here. Yeah, because options can't be cloned. Okay, so I don't think I can do a filter map. I think we need to do this manually ourselves. We need to... Well, you know what we can do? We can still do a filter map. We have to do this multi-line ourselves a little bit. So we have to return the option. But we have to go in a little bit. So we have to say if let some component equal to self.data.getMute data key. Okay, so that gives us the component out now. And then I want to return a sum component.clone. Otherwise, I want to return a none. And then I can collect that together. So I think that'll work. And so the way that filter wrap does is it's basically like filter and then map run next to each other. I return an option, which could be something or nothing. It's going to remove all the nothings and just give me a vector of all the things. So does that mean that this test works now? It does. Okay, so I can successfully query for the thing that I put in. That's great. What I want to do is I want to update it and see whether or not it's updated after this. Okay, so I have the query data. Now I want to mutate that queried data. It's this RCI32. So I think I can, I want this to be mutable. Then I can do a dereferenced queried data is just the I32 itself in memory, plus equals to like 1. Then assert equal that queried data is entity plus 1. In fact, I want to see that it's failing first. All right, what are you? Cannot assign to data in an RC. Say deref mute is required to modify through a dereference, but is not implemented for. Deref mute is required to modify through a dereference, but it's not implemented for standard RC. So if I do this, can I get that out? There's deref. As ref. Not seeing anything else. If I don't, okay, so it's saying like, hey, I don't need to set this to be mutable here. What if I don't dereference you like that? Yeah, okay. So can't use this on a type RC. It's been downcast, so it should know what type it is. Is there a downcast mute? No, okay, I don't see a downcast mute at all. There's a borrow mute though. Okay, so if I borrow mute, what are you? Nothing. Wait a second. Oh, I need to downcast first. Okay, so I downcast as an I32. Then I borrow mute. This gives me that mutable results. Then I unwrap. Like if we look at this, I have a mutable reference to a result. Then I can dereference to query plus. No, it doesn't like that at all. Physics, hello. Maybe try the suggestion to import the trait borrow mute. Yeah, I might need to, although that's for like the object inside, right? Cannot move out of a mutable reference. Move occurs because value has a type results, any which does not implement the copy trait. Consider borrowing the results content. Okay, so if I do this borrow mute, what if do I need to match this? Let me try that. Usually just follow the compiler until you're forced to think. It's not a bad way of doing things. Okay, so what happens if I match this results? I have that result here. So we're gonna get an okay. with the thing in it. So it's going to be the, I don't know, the component. Ah, there it is. Okay. So then I want to take our component, dereference it, component plus equals to 1. It's either going to be an okay or an error with some kind of error. We don't know what this is. But it's not an error, is it? It's like the other data. So I don't really care about this. Like that. I'm not doing anything. Then I don't update you. And then I assert equal that this thing happened. Well, hold on. Binary assignment operation cannot be applied to stat type RC I32. Well, wait a second. I'm trying to dereference you to get inside of you. Well, that didn't work. I need to somehow... Okay, so there's the deref mute. Oh, look at this. Okay, there's div assign. Is there add assign 1? Okay, why did you tell me that, Rest Analyzer? Giving me hope. Okay, so can I deref mute? What does that mean? No, you didn't do anything for me. So I'm gonna multi-line this so I can just see what I'm dealing with here. So temp equals component dot deref mute. What are you? That literally changes nothing. Okay. What if I do this? Okay. It makes it from a mutable reference to an RC I32 to just an RC I32. If I double dereference this, that becomes that. And then it's to 1. Okay. So can I do a component that's double dereferenced plus equals to 1? Okay, can I find the query data in here? Now we have this results here. So I think we need to do the results again. Well, okay. This vec. So I need to do a let read data equals results. So of 0 dot clone dot downcast I32 unwrap dot deref. Okay, it's this like reference to an I32. Now I don't have to have this deref here, I don't think. I can just leave it as an RC and then just becomes query data like that. Okay, cannot assign to data in an RC. Trait deref mute is required to modify through a dereference, but is not implemented for RC I32. So I couldn't, that would mean I would need to add deref mute to each of the types that I send in. Unfortunately, I'm testing with this just like plain type here. I mean, I could deref mute at some point in time. What if I deref mute? As deref mute. Oh. Why are you still lying to me so much? Best analyzer. Okay, so what do we have here? This is coming in as an RC I32. Okay, so you're an RC. Can assign data to that, trait deref mute. So maybe can do this here. So can I do a component dot deref mute? Do I have to let you know that you're mutable? Trait deref mute is required to modify through a dereference, but it is not implemented. So same problem. I'm just sort of like moving around in here. Okay, so if I didn't use this entity here like this, if I created like a struct, so let's just create this down here. Let's say that I had like a struct test location. We have like an X, which is F32. Let's do an I32. This, instead of test location, we'll do test component. So entity, gonna change you to test component is equal to test component. X is 25. We insert test component. We query. So okay, this type we have to test for query for test component. Now this won't work anymore because the component is something completely different now. So downcast this to a test component. And now we have this RC test component. What if I impl test component and I have a pub function? I want to like add to X. So like you can do like increment. You take mutable self. We're not going to return anything. We're going to self X plus equals to 1. finesse it. So we're going to do component dot increment. Okay, so then down, we get our other components. We don't care about that. We downcast you to a test component. You're going to be yelling about, okay, so it doesn't implement debug. Can fix that. Partial equal is also missing. Okay, value moved here. Wait. Oh, right, test component. Okay, so we need to implement clone, copy. No, there's still an error here. Cannot borrow data in RC is mutable. Okay, so if I dereference you, wait, type unknown cannot be dereferenced. So we know that you're a test component at this point in time. I need to get you out and then call increment on you. I want to run this cargo build. Oh, okay. Let's run the test. There we cannot borrow as mutable. Okay. Okay, so trait deref mute is required to modify through a dereference. So deref mute. So can I derive that? Where does that come from? Where is deref mute? Okay, standard ops deref mute. Quite a bot. You're fairly new to Rust, about 3 weeks into learning. You're struggling so hard with ownership, generics, and lifetimes. Yeah, I can see that. It takes a bit of time to sort of like wrap the head around like what's going on behind the scenes. And even then, like we still run into problems with it. Used for mutable dereferencing operations. So if I come to here, do I need to not use RC? I wonder if I'm not going to be able to. So here, let's do standard ops. Actually, I'm in tests here, aren't I? So that'd be right here. Oh, here's deref mute right here. So the fact that it's unable to use this. Okay, there's no deref macro for it. So that means I have to implement it myself. So impl deref mute for test component. So we take a mutable reference to self. Mutable self target. I mean, what happens if I just return self like that? Okay, deref needs to be implemented. Can that be auto? No. Okay, so I need to do that myself too. Please provide, okay, type target equal to test component. Okay. Reach the recursion limit while auto dereferencing. Cool. It's not exactly what I wanted. Now if I do that, type nothing. Okay, so that's cool. If I deref mute here, you can yell at me that doesn't exist. Yeah, no, for enum result. Okay, so if I unwrap you here, then dot increment. Yeah, okay, so reach the recursion limit. So I don't think I implemented the derefs properly. What if I do something like this? We turn, stop. Go back to you. Yeah, okay, so it's trying to auto recurse here. So it's trying to get a deref mute, which returns like just a mutable reference to self, which is this, but somehow it's then trying to get another dereference. So it's like just continuously going through here. Oh, am I only supposed to do that? Like the value of it. Hmm. Hello, Chantilly. So that's not gonna work. Wait, So expected a function pointer for mute, oh, test component. Okay, so this has to be like a test component here. No matter what, I'm still hitting this recursion limit. So I think this is like the wrong way for me to go about doing this. There's got to be a better way for me to get like the query out for like the mutable query. With the dying any though, it's like a little bit rough. I wonder if there's a better way for me to go about doing the query. So instead of just like handing all the data out directly, I wonder if I can downcast it in here. So I wonder if I can do something like I take a type in. So I take like the component type. Which we know has to be like static. And we also know it's gonna be like send plus sync. Like it's gonna be one of these. And we're gonna return, so then we can say like, okay, we're gonna return one of these. So, I wonder if like it would be better for us to like move away from, hey, we query for multiple things at a time. We're just querying for one thing. Just do multiple queries yourself. I wonder if that would like be better for us. Just query for a single type. So then we have a vector of just that type. So it'd be a vector of C. Although it would be a vector of RC, C, and because we clone it, that'll be fine because it's reference counting. If we do that, this changes around a little bit. I don't necessarily even need a query anymore. Then what we do is we say, okay, given the type that we care about, let's get the data key out of it. So let data type. Oh, type ID. It's going to be type ID, of C. So that gives me a type ID, then I can get this out. And then we clone that and return it. So then we're going to return self.data.get mute type ID unib reference. It's going to be an option, so we should do like an iflet. Components. Okay, so that gives me a mutable reference to a vector of this. Okay, so iflet some components. Then I want to return components.clone, which gives us this vector of RC. Okay. But I need to downcast it at this point in time. So we clone. Oh, okay. So this is gonna be fun. So let mute results equals a new vector. I need to downcast into this type here. So we're going to get the components out. Get the components out. Then I need to loop through each of these components. And like this kind of works as like we're cloning the vector with all the components inside. Downcast them and throw them in here. So dot iter dot for each. This is going to get us a component. We can do a to-iter to take ownership of it because we've cloned it. Into iter. Okay, so we get this component, and then I just throw. Okay, we need to downcast this and throw it into type ID. We know that this is going to work because it wouldn't even store in there. So I think I can just unwrap this. It should never error. Should never error. The compiler doesn't know that. So let's say I then do results dot push. Okay, so we have the component. We have to downcast this to type C. But it's now a result. So we unwrap that. And now we have this vec of RCC. Okay, perfect. And then we return results. Okay, so then down here, immediately query for data. Okay, so let results equals data query mute. We're gonna have to tell it that it's gonna be a test component. And I don't think we have to pass anything in. We just say, hey, I just want to query for all the test components. We get the results, which is this vector of that. Then okay, so then I want to get the first one out. So I need to reset this. We know that there's only one that we're getting out, so I might as well just go to 1, 0. So we have this RC test component. We can test to make sure that we got the right thing now. So assert equal that the referenced results, this is result then, is the same as our test component. Okay, cannot move out of index of, move occurs because value test component. Okay, so test component offers that, but RC does not. I need to clone the RC. Oh, let's also remove you because you might be causing problems. Okay, so let's test you, make sure. All right, so you're passing. Okay, so we have the test component out now. If I attempt to update this, so this will be result dot increment that. Right. Okay, so back to this again. Now, if I tell you that you're mute, that won't work. What if I do something like results dot x plus equals to 1? Yeah, okay, so it's exactly the same problem down here again. So we'd have to like impull the deref mute for it. I'm not sure this is a good idea. And I'd be returning essentially self. And is this yelling at me because I'm not returning? Okay, so then I need deref. So same, I feel the same problem is about to happen. Because if I have like test component like this, and just we return self. Yeah, reach the recursion limit while referencing this. Ah. Then cannot move out of view. It totally does. Okay, hold on. Can't compare mutable reference to RC world test component with test component. If I dereference result, yeah, reach the recursion limit. So that's a problem. And here, like if I create like RC new test component and then reference it. Can I assign data to an RC? Yeah, so same exact problem. Like no matter what, I think we have to make sure we do it without dealing with that entire nonsense. So I may have to like look into how some of the other ones deal with this, or like if there's data structures other than RC to use. Maybe we can use like an arc. Maybe there's an RC mute that we can use. Where was RC from? Okay, there's RC get mute. Oh, the inherent methods of RC are all associated functions. This means that you have to call them as RC get mute. Mute value. Wait, really? Hold on. Get mute. Okay, so we do RC new 3. RC get mute. Mutable reference to X. Okay, that's not intuitive. Hold on, so I was doing this wrong. Okay, so I don't need this query anymore. We're not doing that. We have... Okay, so we have... We have the data. So we have the result, which is this RC test component. What I want to do is an RC get mute. Hold on. Too much. Okay. RC get mute. We hand it this data like that. Then we unwrap you. You're an unknown now. No field X and type, mutable reference to an unknown. Okay, expected immutable reference. So if I do that, there it is. Okay, so we plus you to that. Hold on. Then I want you to be a dereferenced result to a test component. Temporary value dropped to borrowed. I could clone you, I bet. So query mail, get this test component. We're gonna clone you. Oh, okay. So I need to do this ahead of time. So query result equals you. That gives us this, and then we're going to give a mutable reference to the query result here. Cannot borrow query is not declared as mutable. Okay, well, fine. It can be mutable here. Called unwrap on a none value. Data.rs line 10. Oh, 109. Okay, okay. So get mute for query result resulted in a none. It got this far though. So if I like debug query result, dot clone. Oh, that's fun. Oh, that's cool. It set up all this for me. That's lovely. I would want to halt on you. Oh, but I don't have it set up, I'm sure. Here, okay, so test component is 25. That's what we saw. So this, we successfully have a test component here. In here. So query result is our RC test component. We get mute this query result. I mean, could I just do this at this point in time? It's going to be query result that x plus 1, and you are query result now. Right, okay. So I need to do the get mute to get this out. I feel like we're really close. Why is this is none? Get mute, mutable reference to X. Is it because I cloned it? Cannot move out of you. With this vector of RC test components. I don't think that get mute will allow me. Okay, can I do iter mute dot map? We're gonna get the, I don't know, like the component, and I want to turn the I want to turn this RC get mute and pass it in the component. I mean, it doesn't yell, but now it's this impl iterator, so then I need to collect it. I need to tell you what you're getting. So you are type, you're a vec. Oh, right, okay, so if I unwrap you. Unwrap you. A vec of test component, essentially? No, a vec of RC test component? What are you supposed to be? It doesn't know. type indentations needed. Okay, so we don't know what it is after we collect it together. So we know at this point in time, it's an iterator of item equals mute test component. So can I say that you're going to be mute test component? No, because you're going to be a vector of this. So you're going to be a vec of mutable test component. Then I want, just give me 0. Cannot move. Okay, so I don't move. Test components of 0. That x plus equals 1. Query results. Position 0. Tests that you're a test component. And dereference you. Temporary value dropped will borrowed. Okay, so query mute. Do I need to clone you at this time? No, okay, so it's dropped before that. Okay, so I need to figure out, like, I feel like we're close, but I also might be completely off. Like, it's a fun thing about like doing these new things. It's like I don't know if I'm like right on the edge of getting it, or if I'm just like completely off the deep end. If I figure out how to make the borrow checker happy with this, to get this out, I might be able to like extract out this way, and it'll be happy then, where I can just mutably query for all these test components for this, like this component here, get that out and clone it. And so I wonder, because like this is this vec-rc test component, I wonder if I need to do like this get mute stuff inside of query. Those are all like questions. Like maybe do the get mute in the query function. Like that's a question to answer. Another potential one is to find out like is there another struct that I need? Like we have this RC. Is there something else that I could use? So here's like RC, but we also have, I know we also have like arcs. Is there other types in here? Or just learn RCs and use that better. I might be misusing RCs a little bit. So that's okay. There's also, let's see, there's arc, but I don't, that's for like arcs are for between going between threads, and I don't need to do that. This is all synchronous, so RC should be fine. If you need mutability, put a cell or ref cell inside the RC. Oh, mutability inside RC. It's very common then to put a ref cell T inside of shared pointer types to reintroduce mutability. RC ref cell. Okay. Or more likely, use an ref cell inside the RC. Okay, I think that's what I need to do. But that's gonna have to be tomorrow.